Hello everyone, welcome to yet another video on our channel Euclid Mathematics. So we have started a lecture series on ring theory. If you wanted to see more videos on ring theory, you can check it through my playlist. In my today's video, I will explain to you all one of the important topic from ring theory, which is an irreducible polynomial. Okay, so already I uploaded some of the videos on irreducible polynomial on my playlist. But before understanding irreducible polynomial, we need to understand first of all irreducible element. Okay? So irreducible polynomial, in shortly, we say that irreducible polynomial means we cannot factorize that polynomial, or we can write that polynomial in the form of a unit element into the polynomial. Okay, that means one element whose power is 1 and other one is a unit element. Okay, so that means we cannot factorize that polynomial that we call is the irreducible polynomial. But now this is time to understand what is meant by irreducible element, because this one is most of the important topic for our further topics. Okay, so after of that we are going to learn Galois field and extension field, splitting field. These things we are going to learn. But before of that we need to understand what is meant by irreducible element. So let's get started to the definition of irreducible element. I will explain some of the example here too. Okay, now see here the definition of irreducible element. It says that if R is an integral domain. So what is meant by integral domain? Commutative ring with unity. Okay, commutative ring with unity, and it has a no zero divisor. That means if we consider two element from the ring that both are non-zero, that means their dot product non-zero. If their dot product 0, that means one of the element from that ring has to be a 0. So we call it as the integral domain. So if you have R is an integral domain, a non-zero non-unit element of R. Okay, so I consider A belongs to R as a non-zero non-unit element. So non-unit element means, first of all, what is meant by unit element? Unit element, it says that it has a multiplicative inverse. So if A is a unit element, that means A has a multiplicative inverse in our certain group. Okay, so if a non-zero non-unit element A belongs to R, that means A from that integral domain, which is a non-zero and non-unit. Non-unit means it do not have inverse, and it is value is having no value non-zero, is said to be irreducible element. When we said it is the irreducible element of our integral domain R, when we get the A which is equal to B which is equal to C, and the B and C which is from that integral domain R. Okay, so we have A non-zero non-unit element, and we get the value for A which is equal to B and C, which is from a ring which is the integral domain, and either B is unit or C is unit in our integral domain. If B is unit, that means it has a multiplicative inverse, or C is unit means it has a multiplicative inverse. Okay, one of them has a unit in our integral domain, but A is a non-unit. Remember, if we have here the element A which is a non-unit, but it comes equal to the unit element, and one of them has to be a unit here. If this condition hold, then we say that A is a irreducible element of our integral domain. Okay, so let's see some of the example on our integral domain. Once we see some example, concept will get very clear. Okay, now see here example first I consider as a which is equal to 11. It is a prime number, and we have to check is it irreducible element over Z or not. Okay, so we know that A which is equal to 11 is irreducible element over Z. Okay, so but let's check it how it comes. So 11 can be written as the multiple of two numbers. Okay, so 11 can be written as multiple of a two number, 11 into 1 which is 11, or 11 can be written as minus 11 into minus 1. Okay, so I got the two element B and C. Okay, B and C which is equal to 11, B into C which is equal to 11. Okay, so their product comes 11, but we can see here 1 and minus 1 is unit in a Z. How it is unit in a Z? 1 has a multiplicative inverse which is also 1, which belongs to in a Z. Okay, 1 has a multiplicative inverse minus 1, so it is 1. Okay, that means I found it here the element which 11 and minus 1. Okay, one of them is here unit. Okay, so we can see 1 and minus 1 is unit in a Z. My 1 and minus 1 which is unit in a Z. Okay, because it has a multiplicative inverse in Z. So A which is equal to 11 is a irreducible element in a Z. Okay, so I got the element B and C which is a 1 and minus 1. Okay, so that A which is equal to prime and A which is equal to minus prime, okay, are irreducible element of a Z. Okay, so if we can write A as a prime and A as a minus prime, then we say that it is the irreducible element of Z. Okay, I consider here general case for our first example. Now let's see one more example where the unit element, non-unit element which do not have irreducible element. Okay, now let's check that example here. So I'm having next example, A which is equal to 10 is a irreducible element of a Z. Okay, so A which is equal to 10, so 10 can be written as a product of a two number, 2 into 5. Okay, 2 into 5, we have to write the product of number as it is a factors are there. Okay, so 10 can be written as 2 into 5. B and C, Okay, so I got the B here, C here. Okay, but none of them is a unit. 2 is not unit and 5 is not unit in a Z. Why it is not in unit? Because 2 has a multiplicative inverse in a Z. 2 has a multiplicative inverse which is 1 by 2, which is not in Z, and 5 also has multiplicative inverse which is not also in a Z. So neither 2 is unit nor 5 is unit. That means A which is equal to 10 is not irreducible element of Z. Okay, so we have to check only the definition for unit element, and we have to check whether our polynomial element which is irreducible or not. Let's see one more example here. Okay, so next example, A which is equal to 1 plus I. We wanted to check that it is irreducible element of Zi or not. So try to write that non-zero non-unit element as a product of two elements. Okay, so 1 plus I written here, A plus IB and C plus ID. I just consider here it's a factor polynomial. It is here A plus IB and C plus ID. So A and B, A, B, C, D are taken from that is Z. Okay, I, B, C, D is from Z. So take the conjugate of 1 plus I. We wanted to find out the two elements where one of them is unit or not. Okay, so 1 plus I is having conjugate 1 minus I. Okay, only conjugate term change the value for I. So 1 minus I it is here. So 1 minus I it written as, I consider here A minus IB and C minus ID, because 1 minus I in the form of minus it is here. So I consider their product as this one. Okay, so multiply 1 plus I into 1 minus I, then we will get the next value. Okay, so multiply 1 plus I into 1 minus I, 1 plus I into 1 minus I. So 1 plus I consider A plus IB, C plus ID. 1 minus I considered here A minus IB, C minus ID. Okay, A minus IB and C minus ID. So A plus B into A minus B. So A square minus B square. So A square means 1 square minus B square means I square. I square is minus 1 minus minus 1, which remain 2. So A plus ID, C plus ID. So A plus IB, C plus ID, A minus IB, C minus ID. Okay, so you can see here A plus IB and A minus IB. So A square minus B square. Okay, that means A plus B and A minus B, it has a square. It has a square of A square minus B square. Okay, so A plus IB, A minus IB. That means A square minus under bracket IB square. So I square is minus, minus minus plus, and B square remains same. Similarly, C plus ID, C minus ID, it remains C square plus D square. Okay, so I got the value for multiplication of these two sides here, 2 which is equal to this A square plus B square and C square plus D square. Now let's verify whether which one of is a unit or not. Okay, so if I consider A square plus B square as a 2, then C square plus D square, it is multiplicand here 1. Okay, so 2 means 2 into 1. So A square plus B square is a 2, then C square plus D square is a 1. Okay, if A square plus B square is a 2, C square plus D square is 1, then we write C plus ID and C minus ID as 1. Okay, C square plus D square. So we can write C plus D square, C square plus D square as a C plus ID and C minus ID. Okay, and we know that their multiplication it gets C square plus D square, and if the product of these two numbers which is a 1, then we write one of them is a unit, because if one is a unit, then automatically it will become 1. That means this, if C plus ID has inverse C minus ID, it get 1, or C minus ID has inverse C plus ID, it gets 1. Okay, so that means one of them is a unit, then C plus ID is a unit in Zi. Okay, so if now next condition is still remaining, which is a case second. If C square plus D square is a 2 and A square plus B square is 1, if this condition hold, then we can write A square plus B square is 1 as A plus IB and A minus IB. Multiply these two terms, you will get the original term. Okay, so if the multiplication of these two is a 1, then we can say it here, one of them is a unit element of here. Okay, so if A plus IB is inverse A minus IB, then it will 1. If A minus IB has inverse A plus IB, then it will come 1. Okay, so one of them is a unit. So A plus IB is a unit in a Zi. That means I got the C plus ID also has a unit in a Zi. A plus IB is a unit in a Zi. Then by using two case first and case second, we can say here either C plus ID or A plus IB is having unit, okay, in our Zi. That means if one of them is a unit, then we say that A which is equal to 1 plus I, which is an irreducible element of Zi. Okay, so that one is quite easy. Just we have to find out the factors of our given number. Okay, what it comes. So in my first example, I consider 11 is the multiple of 1 into 11 and minus 1 into minus 11. So this way you can generate the factor. So next example here, alpha which is equal to 2, which is irreducible element of Zi or not. Okay, so you can do it for your homework. If you have any doubt related to this example, you can comment me in the comment box. I hope so you all have understood my today's lecture. If you have any difficulty, let me know. I will upload similar videos on my channel. So thank you everyone. Thank you for my today's lecture.